Hi, this is Mr. Nazarian. Our lesson objective today, I can understand and find equivalent fractions. It's a 5th grade standard, numbers and fractions, A. The first thing that we need to do when we start this lesson is we need to remind ourselves, what are fractions? What is a fraction exactly? A fraction is a part of a whole. So for this first example, we have a square, right? And it has been divided into how many parts here? You can see I had a square, I drew this line here, which created how many equal parts. And that's a really important thing is when we're talking about fractions and dividing a whole into parts, the parts have to be equal. So this part is equal to this part. So how many parts do we have? We have 2 parts, right? So that number, the number that tells us how many total parts we have of the whole, is called the denominator. The denominator is the number on the bottom of a fraction, which tells you how many total parts there are. Now, this fraction here, what we're going to do for this is we're going to look at what fraction of this square is shaded. How much of it is blue? So that means how many of these 2 total parts are shaded blue. Obviously, it's 1, right? So 1 is going to go on top here. And the number that goes on top of a fraction is called the numerator. The numerator is the number that tells you how many of the total amount of pieces are shaded, were eaten, were shared, whatever it is that the problem is asking us that we're trying to solve for. So in this case, we're doing how many of them are shaded. One piece, one part, is shaded out of the 2 total parts of the square. All right, so that's just a real quick reminder on fractions. And now we're going to look at this exact same shape, right? We have this exact same amount here. Again, this is what fraction? 1/2, right? So we have 1/2 still. But what if I grab this line and I divide this same exact piece up with the same amount shaded, but I divide it up, put a vertical line here where now there are 4 parts. What would this fraction be called? So again, we're looking at, I have a line right here, right? The number on bottom is the total amount of pieces. So because I sliced it vertically now, we've got 1, 2, 3, 4 pieces on the bottom. That is called the denominator, right? And how many are shaded? There's 1 here and 1 here. There are 2 shaded. So an equivalent fraction means that the fraction, the numbers themselves look different, right? This has a 1 on top, this has a 2 on top, this has a 2 on bottom, this has 4 on bottom. They're different, right? They look different, right? The numbers are different. But the value of those fractions is equal. That's why they are called equivalent fractions. They are equal. So they have equal value. So the amount that's shaded here is the exact same amount as what is shaded here. And I can show that again real quick just by moving this. It's the exact same amount. I haven't changed the value of how much is shaded, right? Nothing's changed besides how many pieces, how much I've divided it up into. But the amount that's shaded and this total amount of the square is not changed, right? So an equivalent fraction has equal value. It's just that the numbers themselves, the numerator and the denominator, those numbers have changed. Okay, so we'll look at a couple more here. So we've got another fraction here. Go ahead and tell me, what would this fraction be called? That's right. It is, there's 1 shaded out of 3 total pieces, so it is 1/3. Now what if we look at the exact same fraction, 1/3, but I take another line and I divide it up like so? What would this fraction be called now? Well, we've got, now instead of having 1 shaded, because I cut this in half here, we've got 1, 2 pieces that are shaded out of 1, 2, 3, 4, 5, 6 total pieces. So we have the numerator, the number shaded, over the denominator, the number of total pieces including the ones that are shaded, so 2, 6. So that tells us that same value, 1/3 is the same value as 2, 6. It is an equivalent fraction. Last one. Here, what would this fraction be called? Okay, we would name that 3 shaded out of 4 total pieces, 3/4. And if I took this exact same 3/4, but this time I'm going to grab a couple of lines. I'm going to put one right here, do this as well as I can, one right here. So now, same value, same amount is shaded purple there, but what would this fraction be called now? All right, well, so again, if we want to do the numerator first, we can count how many are shaded first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 shaded. 9 is the numerator. Over total, we have 9, 10, 11, 12. Over 12 total. So 9/12 is equivalent to 3/4. I want to do a quick thing here. I want us to look at this. So we have 3/4 is equivalent to 9/12. 1/3 is equivalent to 2, 6. 1/2 is equivalent to 2/4. I'm going to write those down real quick here. So 1/2 is equal to 2/4. 1/3 is equal to 2, 6, and what was the other one? 3/4 is equal to 9/12. So I want you to take a look at those and see if you see any pattern at all, any relationship with these numbers. So we're looking at 1/2, 1/2 and 2/4. How are these numbers related? Again, looking at, and anytime we're looking at pattern, we want to look at many examples, right? So when then we here have 1/3 is equal to 2, 6. How are these numbers related? And 3/4 and 9/12. How are these numbers related? Okay, so think about that. Any connections at all that you can make. Okay, so you may have noticed here that when I'm looking at 1/2 and 2/4 here, the numerators here, 1 and 2, I've doubled the 1 to get a 2, right? And what did I do to this 2 to get a 4? Well, if I double this 2, I'll get a 4, right? So, well, that's something, a connection we can make here. So, oops, if we multiply this by 2 on the top, and we multiply this by 2 on the bottom, so that worked, right? Then we have this 1/3. What do we do to 1 to make it a 2? Again, if we just double it, if we multiply it by 2, we get 2. What do we do this 3 to make a 6? Oh, well, if I multiply that by 2, right? If I double this 3, I'll get a 6 as well. All right, now let's look at this, 3/4 and 9/12. So what's the relationship of this 3 and the 9? It's not doubling, right? Well, how much more is 9 than 3, though? It's 3 times more, right? It's triple. So 3 times 3 equals 9. What about 4? What's this relationship to 12? How many 4s are there in 12? Oh, there's 3. So hopefully you notice this pattern of, if you multiply the top and the bottom of a fraction by the same number, you will get an equivalent fraction. It only works if you multiply the top and the bottom by the same number. Now later on we can work on taking equivalent fractions with bigger numbers and making them smaller by, we just do the opposite. We would just divide, right? So 9 divided by 3 equals 3. 12 divided by 3 equals 4. But you have to do the same thing to the numerator as the denominator. So you're either multiplying or dividing the same number on the top and the bottom. So there we go. So that's all that you need to do to find equivalent fractions. We will work more on that tomorrow. See you then. Bye.